It's my privilege to tell you something in the next 20-30 minutes about sustainability and how Rittal sees this. We do have a product portfolio which is perfect for this type of thing. Here we have control cabinet cooling devices, cooling units, and here you have some control cabinets where we can use this. You see the advantages. You can reduce CO2 emissions to a great extent while operating these units. The savings can be up to 1 ton CO2 per year, just because you consume much less energy. And compared to the manufacturing of these devices, it's actually just 1/10 of the consumption, which means, or let's put it differently, I'll show you how we achieve that in a minute, but let me first give you a couple of numbers which might be quite impressive. We had a look at how many control cabinet cooling units are in operation in Europe, and on the basis of our sales numbers and our market share and the duration of use of these devices, we assume that there are about 2 million control cabinet cooling units installed in Europe. And if only 1/3 of them were to be replaced by more efficient units, well, about 480,000 tons of CO2 could be saved per year, or 1.1 megawatt hours of power. 1.18. And this is about the CO2 emissions of 270,000 SUVs that would generate CO2 emissions. So this shows you the savings you can achieve if you use Rittal control cabinet cooling units. Now, how is it that we were able to state this? Well, we did lots of studies, and I'll show you in a minute a couple of examples with new control cabinet cooling units. And originally, we had different research projects, including with the PTW in Darmstadt. We began with the Maxim project, and we continued with the Phi factory and then ETA factory. And the objective was always to check to see how a control cabinet cooling unit could be made more efficient. Now, one approach we had even back then was that we said we should use power control in our air conditioning. In other words, we would only provide the power that's necessary to achieve a certain temperature level and maintain it. And you can see that here if you look at the chart. Conventional cooling devices would use hysteresis, and that means they would be cycled across a certain temperature range. As a rule, it's between 35 and 30 degrees centigrade. They have hysteresis of 5 Kelvin as a rule, and the inverter ensures that you only have the power coming from the cooling unit to maintain the temperature at 35 degrees. And then we've added something to this. The additional point is what we call hybrid technology. Hybrid means that in these cooling units, we have installed what we call a heat pipe. Now, we came up with the idea of a heat pipe because in different studies, we determined that cooling units very frequently are maybe not wrongly sized, but oversized. And this means that often the customers have certain requirements of their machines, of their systems. For instance, in the automotive industry, as a rule, it's 50 degrees, 55 degrees that they still have to work at perfectly at that temperature. Now, this means that if you have a cooling cabinet interior temperature of 35 that you don't want to go above, you need a cooling unit of a certain size. Now, in our field analyses we determined that very rarely do you ever have an ambient temperature of 50 degrees centigrade. It's usually 20, 22 degrees in your production building. So, as a result, you could use an air-air heat exchanger. But customers want to have safety and security so that even if there are extreme temperatures, the machinery and equipment would still always work, because availability of the equipment is why they even use these cooling units for their control cabinets, and that's why we said we could combine it with a heat pipe. And what this means is this. You see that on the next chart. I hope it works. So there you have passive operation on the left-hand side. Passive operation means that only the heat pipe is working, which means you don't need a compressor. And as a result, you are very efficient in removing the heat from the control cabinet because of the high delta T, and you have high amount of savings compared to normal conventional devices. Now, if the temperature difference changes, if the environmental or ambient temperature goes up, then we have something else that kicks in. The compressor and the fan now are run at the speed that's necessary to maintain the temperature. And the heat pipe, too, also takes heat out of the control cabinet, and this, too, is very efficient. And then if the ambient temperature does go above what you have or want to have inside the control cabinet, you switch off the heat pipe, and the cooling unit then gives you the necessary cooling to keep the control cabinet at the temperature you wish. And we've been able to do many tests to prove that the efficiency here is about 70% to 70% less energy consumption compared to conventional units. And we also tested this in different areas. Here you see the automotive industry, Ford in Germany, and Audi in Germany. Voigt Turbo, that was one of our customers too. And they too switched to this technology. There you see all the savings. I'd like to mention another important point too. Energy efficiency, sustainability doesn't just regard the product. It's also about how you use the product. And here, for a number of years, we've offered what we called an IT interface, IoT interface. So it's possible to interconnect these devices. You can connect them into the customer network and check what the system status is for the devices. Now, the advantage of this is that you can do remote monitoring of the devices from a central location. You have a clear overview over the status and condition of the devices, and if there are any faults that occur, you can analyze the fault messages and you can see recommendations for what to do. And theoretically, this information could also be passed on to Rittal service. And this, of course, means that you have much higher efficiency because you immediately know what's going on with the device, what's got to be done in order to make sure that the device gets back into perfect condition. And our service, if it's on site, is able to immediately do maintenance on the device, on the equipment. One specific example is this. We saw in some of our field analyses that a lot of the devices had very dirty filters, and dirty filters means there's less air going through the cooling unit. That means there's less cooling, and the device has to run longer, and the compressor has to work more, so that means you have a much higher energy consumption. And with a monitoring system like this, you know exactly what the status and condition of the device is. You know exactly when the filter was changed or when it was supposed to be cleaned or exchanged, and you can do that before the device is in a status and condition where the energy consumption is much higher. And this too is what sustainability is about. As I just said, Rittal, of course, doesn't just think about the product as such. We also think about how the products are used, and we think about documentation as well. And this is an important point. We call it the Rittal ePocket. Now, the Rittal ePocket gives you the possibility to completely document your control cabinet, not just the cooling unit, but also the components in the control cabinet. We came up with this idea because we saw again and again. I see you smiling. You've seen it before, I'm sure. We see that in the control cabinets you have wiring diagrams and holders with paper that's torn, and you don't know whether it's up to date, this documentation, whether something's changed. And so What's important is this. You need the documentation not just for the startup or the project phase, you need it in particular when the control cabinet is in use, in production, and maintenance and repair has to be done. And we did a customer survey, and most of our customers, or majority, more than 55% of customers said that during the life cycle of their equipment, a lot of changes are made, updates and so on, and if the changes and updates are not reflected in the documentation in the control cabinet, then later on this can lead to mistakes. So our approach is this. In the control cabinet, we have a matrix code, and you can scan that. And then, using that code, you access the ePlan cloud. That's our sister company, ePlan. And you can set up a file there, it's what we call a digital wiring diagram holder. It's not just which cooling unit and so on. It's exactly what control cabinet, what components are in there and everything. And then you can store this machine documentation at a central location. You have a clear workflow. You can work error-free. And you also know during the entire life cycle of the machine what changes have been made, and you have access to all of this documentation. And this is done by means of a matrix code. As I said, you can scan it, and if you know exactly where the documentation is, you can also access them in the ePlan cloud directly and have a look at them there. And we've expanded this even together with the ZVEI Association for different components in the control cabinet. We have determined the carbon footprint, and that means we are able to define the carbon footprint for the entire control cabinet, not just for the cooling unit, but for all of the components in the control cabinet. And this also can be documented. Okay, that's the control cabinet. Now let's say we take another step. Then this leads us to our sister company, German Edge Cloud. And they've developed a new product there. It's called OnSite. And incidentally, you can go to the booth and have a look at this F11. Isn't it the booth? That's our company over there. And OnSite is a digital production system, which makes it possible to achieve transparency in production and to show this, to demonstrate it. And the objective of all this is, first of all, to make your factory more transparent based on a digital production twin, which means that by creating a digital replica of the factory, you can optimize your production processes, and it can give you clear recommendations for what to do with your controls, with the reports. You have possibilities for finding optimization potential, and this also means that energy consumption can not just be visualized, but it shows you exactly where you have potential for optimizing this, cutting energy consumption. So it shows a very clear comparison example of energy consumption per part, if you, for instance, produce different parts. And in our production, for example, where in Haiger we produce housings, we've set this up. And now we're able to see how high energy consumption is, what's the product carbon footprint of each control cabinet, for example. And the next step here on this chart is the collaborative factory, number 2. And this means that you can partially automate the factory, and you have analysis possibilities. You can recognize where there is variance between target and actual, and you can make the necessary optimizations, improvements there. Is there something that's getting out of hand? How do you have to escalate things? And so on. And in any case, as I was just saying, you have an energy footprint for each of the components. The next step then would be the self-optimizing factory, which means that the equipment can communicate. All the pieces of equipment can communicate with each other so that the process logic would optimize itself, organize itself, which means that your consumption could be balanced ideally. And then on the far right-hand side of the chart, you have a lights-out factory. I'm not exactly sure what that means. I thought you would switch off the lights and the factory wouldn't work. But no, that's not true. You don't need lights for the factory to run because the machinery and the equipment would self-organize so that people wouldn't even be necessary there to operate the factory. Now, we've tried to implement some of these things in our factory in Haiger, as I mentioned. And here you see the paint shop in our Rittal factory in Haiger. There you have that on-site component. And with that component, you can portray the virtual factory. You can see what the condition and status of the different parts of the overall system are. And then with your dashboard, you can conduct analyses and see exactly what the situation is with the energy, what your consumption is, and so on. Not just with regard to electrical energy, but also with regard to gas consumption, for instance. This is quite important for us because last year, for example, in the fall and in the winter, we had to have keep a close eye on our gas consumption, reduce it as far as possible, because as a result of the war in Ukraine, gas supply did become a critical point. And this was extremely important for us, in particular in the paint shop. And we were able to see there where we could optimize things, where there's potential for savings, and how we could control things more efficiently. Okay, that was it for me. On the subject of sustainability, if you have any questions, I'd of course be pleased to answer them.